In today's episode, we take you inside a massive open-air recycling facility. Welcome to Factory Founder, where machines meet their final chapter and a new one begins.
In a vast, sun-scorched expanse where industry meets decay, thousands of machines lie frozen in time. These are not ordinary machines. Each one was once a technological marvel, a symbol of power, precision, and engineering dominance. Now, they sit silent, weathered, broken, waiting. This is the final destination of the CV-22 Osprey. Scattered across this open recycling ground, their tilt-rotor wings locked in unnatural positions, their fuselages torn and rusted, these aircraft form a graveyard of innovation. Paint peels away under relentless sunlight, metal oxidizes. Dust settles into every exposed cavity. What once flew across continents now rests motionless, reduced to raw material awaiting transformation. But this is not the end. This is where a new life cycle begins.
Watch the cable. All right, lowering it down.
The journey starts with arrival. From distant military bases and storage facilities, aircraft are transported into this massive open recycling yard. Heavy-duty transport convoys carry their weight across rugged terrain, kicking up dust as they approach the intake zone. Each aircraft arrives worn, aged, and often severely degraded, its structure weakened by years of service and exposure.
Keep it steady on the right side. Copy that. Increasing tension. Check the stabilizers. Watch for debris.
Teams of inspectors approach. They study every inch of the surface, recording corrosion, damage, and missing components. Identification tags are applied. Digital records are created. The aircraft is no longer a vehicle. It is now an industrial asset, catalogued, tracked, and prepared for systematic breakdown. But before dismantling begins, safety takes priority. Inside this Osprey, dangerous substances still remain: fuel, hydraulic fluids, pressurized systems, and electrical energy. Left untreated, these could pose serious risks. Hazard teams move in. Lines are exposed. Fuel is carefully drained through reinforced hoses into sealed containers. Every drop is controlled, every connection monitored. Hydraulic systems are depressurized, releasing built-up energy that could otherwise cause catastrophic failure during dismantling.
Check clear, moving to port side. Keep it steady. Looks like the pressure is holding. Copy that. Monitoring flow rate. All right, systems check complete on the left nacelle. Right side check's good to go. Let's disconnect the fuel line. Stand clear. Roger that.
Electrical systems are disconnected, batteries removed, wiring neutralized. This phase is slow, precise, methodical, because before destruction comes control.
On the nacelle. Copy that. Marking it down. Use the ladder for inspection. Follow all safety protocols. Understood.
Once the aircraft is declared safe, the true dismantling begins. The most recognizable components are removed first. The massive tilt-rotor blades, once responsible for vertical takeoff, are detached using cranes and hydraulic tools. Rusted bolts resist, metal groans under pressure, but eventually, the connection breaks. The blades rise into the air, swinging slowly as they are transported away.
Slowly.
Engines follow.
Looks good. Lower down. Watch the clearance. And set. Got it.
Heavy, oil-stained, and worn by years of operation, the turboshaft engines are carefully extracted. These are complex systems, removed not just as scrap, but as valuable material sources. Wings are separated, landing gear is removed, external panels are stripped away. With each step, the aircraft loses its identity. What remains is a hollow shell. Inside, the dismantling continues. The cockpit, once filled with advanced instrumentation, is now a fragile, corroded space. Technicians remove what remains of control panels, wiring systems, and avionics modules. Every component is extracted with care. Wiring is pulled out in long, tangled bundles. Hydraulic lines are disconnected and removed.
Watch the harness.
Clear. Bring it down to 12.4.
Insulation is stripped from the interior walls, revealing the raw skeleton beneath. Seats, structural frames, and internal supports are cut free and lowered to the ground. Piece by piece, the interior is emptied, until nothing remains but a skeletal structure of aged metal.
Dropping steadily. It's stable now.
Good, stop.
Finished.
Now begins the most aggressive phase, structural sectioning. The aircraft is no longer dismantled gently. It is cut. Industrial plasma torches ignite with intense brightness, slicing through thick fuselage sections. Sparks cascade downward, metal glows under extreme heat. The aircraft is divided into large segments: fuselage, tail, wing roots. Each cut is supported by cranes to prevent collapse. Each section is controlled as it separates. What was once a unified machine is now a collection of fragmented structures. These fragments are transported deeper into the processing zone, and here the transformation accelerates. Massive industrial crushers begin the next stage. Sections of the CV-22 Osprey are fed into steel jaws that compress with immense force. Metal bends, cracks, collapses inward. The sound.
Keep it steady. Looking good. Yeah, nearly finished this one.
From here, the process becomes more refined. Conveyors move shredded fragments through a series of advanced sorting systems.
Keep it moving slowly. Roger that. Maintain the speed.
Magnets lift ferrous metals. Eddy currents separate aluminum. Density tanks divide materials based on weight. Each material follows its own path. Aluminum is cleaned and purified. Titanium is isolated and inspected. Copper wiring is stripped down to its core.
The optical scanner is picking up high-grade aluminum. Activate the air jets for separation.
Even composite materials are broken down through chemical and mechanical processes. Nothing is wasted, every fragment is evaluated.
Okay, this one's a solid titanium piece. Got it, looks good. Into the pile. Keep it moving. Clear. Is that clear?
Every resource extracted. At the same time, environmental systems work continuously. Dust is captured through filtration units. Fluids are treated and neutralized. Contaminated water is cleaned before being released or reused. This is not just destruction. It is controlled, regulated transformation. Once materials are refined, they enter the final stage of preparation. Massive presses compress metal into dense blocks. Copper is wound into coils. Materials are sorted, labeled, and catalogued. Each batch is tested for purity, verified, approved. What began as a rusted aircraft is now a collection of valuable industrial resources, ready to move again.
Keep an eye on the leading edge.
In the final phase, logistics take over. Cranes load compressed metal blocks onto transport trucks. Containers are secured with chains and locking systems. Every shipment is documented, tracked, scheduled. Convoys begin to move, slowly at first, then steadily. From there, the cycle continues. The metal will be melted, reformed, reused, perhaps in construction, perhaps in machinery, perhaps even in new aircraft. Back in the yard, the operations quiet down, machines power off. Workers clear the area. Where once stood a complete aircraft, now remains only open space, ready for the next arrival.